everyone, this is Christian with Self-Taught CRE, and today I'll be building an amortization table from scratch. And what we're looking to do here is we're looking to be as efficient as possible. We want to build an institutional grade amortization table, and so we'll have the basic functionality involved with an amortization table, and so we'll be able to input a loan amount, the interest rate, an interest only period, maturity, amortization, and we'll calculate the monthly payment, annual payments, and then the balloon payment as well. And then as I'm building the schedule, we'll go ahead and call out all the shortcuts that I'm using along the way. That way you can decrease the time that it takes to build these things and hopefully leave this video feeling confident that you can do this on your own. And so here we have a blank sheet as we typically do. And what we're going to do here is start by renaming the sheet name using the shortcut Alt-HOR. And then we're going to call this amortization table. And then this is personal preference, but I like to remove the grid lines, and so the shortcut to do that is Alt-WVG, and there we see our grid lines are gone. And so now I'm also going to adjust column A's width by using the shortcut Alt-HOW and setting it to a value of 2. And then columns B and C, I'm going to select both by holding down Shift and the right arrow key and then changing the column width here using Alt-HOW again as our shortcut to a value of 20. And the reason why I'm doing that is because in columns B and C, this will house our loan summary assumptions. And so we'll go ahead and type in loan summary here in cell B2. And what I'm going to do, or what I want to do rather, is I want to show the loan summary centered across columns B and C. And so instead, and you'll see this often in models floating around throughout the industry, many people will merge center. And that's okay, but once you really get deep into modeling, you'll see the issue with this because once you want to manipulate the spreadsheet, having merged and centered cells makes it much harder to manipulate. And so to get the same end result, what we're going to do is first and foremost undo what we just did using Control Z, and instead we're going to center across selection. So I'm going to hold down Control 1, and that will open up this Format Cells menu. We'll click into Alignment here, and then under Text Alignment, under the Horizontal menu, we're going to click Center Across Selection. And now their columns B and C are not merged and centered. And so now we'll go ahead and format this header. First thing I'm going to do is add a border around this using Alt-HBS. There's the border. We're also going to add some fill color using Alt-HH. And we'll select the ice blue, which is Self-Taught CRE's color. And then we're also going to change the font color of loan summary. We want to show white here, so Alt-HFC. We'll select white, and then finally Control B to bold. And so now we'll lay out the line items that we need here. First will be the loan amount. Then we're going to have the interest rate. Then we're going to have the interest only period. And then we're going to have the maturity. And then many people ask, what is the difference between maturity and term? There's absolutely no difference. And so in parentheses here, I'll just put the word term. And then we also have the amortization. And then within this loan summary, we're also going to look at the monthly payment, the annual payment, and then finally the balloon payment. And people ask, what is a balloon payment? Sometimes it's referred to as a bullet payment. They are the same thing. All this means is that this is the lump sum that is paid back at maturity, and this happens directly as a result of the amortization period being longer than the maturity period. But I'll get into that once we calculate it, and it'll make much more sense once we have numbers flowing through our model. So now I'm going to finish formatting the rest of the table by adding a border around this selection here using Alt-HBS. Again, there's the border around this selection as well. I can use the F4 key to repeat what I last did. So there's the border around again. And then we're also going to add fill color. Alt-HH will allow us to do that, and we'll select this first shade of gray. Now we'll go ahead and input our assumptions. We'll say that we have a loan amount of $8 million. We'll say that we have an interest rate of 7.5%, an interest-only period of 12 months, a maturity of 120 months, which corresponds to 10 years, and then an amortization period of 360 months, which corresponds to 30 years. And so now what we need to do, because we're building this as an institutional grade model, we definitely want to change the font color here since these are hard codes, these are manual inputs, and we want to denote not only to ourselves but to whomever is going to be using the model after us that these are hard codes. It just makes it a lot easier when things are formatted correctly. And so we'll select these inputs here, holding down Control Shift and the down arrow key, and then Alt HFC will allow us to change the font color. And I have it in recent colors here, but so everyone knows, if I click M for more colors, I can navigate to custom, and the color code that I want here is red will be 0, green will be 0, and then blue will be the value 255, and we'll hit enter. And then there we can clearly see that these are hard codes and that we should change this, and these changes will flow throughout our model. And then one other change that I'm going to do here is I'm going to have these numbers formatted such that it shows the word months following it. So I'm going to select these three cells here and then Control 1 to open up the Format Cells box. Instead of alignment, we're going to select the number option, go down to Custom, and then beneath General, we have 0 here. We'll select that. We'll input a space here, and then in quotations, we'll have the word months, and then close quotations, and we see that the sample says 12 months. And so Excel isn't reading this as 12 months. It's still going to read it as the number 12. Just to us, we can see the word months here. So if you did not do this and you went and typed in 12 months, Excel is going to return an error to you if these cells are involved in a calculation. So in order to have this nicely formatted like this, you do need to go through the Format Cells option. So now to calculate the monthly payment, we can use the PMT function. And so we'll type in equals PMT. And for those of you who don't know, every function in Excel will have a short description that populates here. And so we see that this PMT function calculates the payment for a loan based on constant payments and a constant interest rate. That fits our description here. So we'll go ahead and click Tab, which will allow us to begin inputting our assumptions into the function. And so the first thing that we're asked to input is the rate. And so the rate that we want to input is the interest rate, which is 7.5%. But since this will be a monthly amortization schedule, we want to take this rate and divide by 12. For the number of periods, a common mistake that many people do is inputting the maturity. We're not concerned with that here just yet. We are always going to input the amortization. And then finally, for the present value, the PMT function defaults to returning a negative value. And so to flip the sign, we're going to start with a negative first, and then the present value will simply be the loan amount that we have here. And so we'll close parentheses and see what the output is. We see that the monthly payment is just shy of $56,000. And so to calculate the annual payment, there are 12 months in a year. We'll take the monthly payment, we'll multiply by 12, and there is our annual payment. I'm going to skip over the balloon payment for now because this will be a difficult concept to explain without having the amortization table there. It's just much more helpful once we've built it out and show what this is with real numbers. Column D, I'm going to adjust the width. Again, the shortcut to do this is Alt HOW, and then we could input the value 2, which is fine. But I'm going to undo that, and instead I'm going to get us accustomed to using the Paste Special menu. And so Control C in column A, and then I'll go back to column D, and then Alt ES will open up the Paste Special menu. And then each one of these words has a letter underlined. So if I click F, it will paste the formulas. V, it'll paste the values. I want to paste the column width, so I'm going to click W and hit enter. And there, column D has been updated to a width of 2. Now for columns E through just about to L, I want to adjust the column widths here as well because these columns will house our table. And so Alt HOW again is our shortcut to do that. And we'll set the column widths to a value of 15. So now we're ready to build out the actual table. And so column E, we're going to have the month, then we're going to have the year next to it, then beginning balance, then we'll have the interest payments, we'll have the principal payments, we'll have the total payments, we'll have the repayments, and then we'll have the ending balance. And now we'll go ahead and format this. We'll hold down Control Shift and the left arrow key to select everything here, Alt HAC to center align this, Alt HH to add our ice blue fill color, Control B to bold, and then Alt HFC to change the font color to white. And then finally, the last thing that we're missing is the border around, just as we have on the loan summary table, and the shortcut for that again is Alt HBS. So now we want to make this a 30-year amortization schedule, and so we're going to need 360 months showing here. So we'll start by typing in 1 here, and then beneath it we'll add 1 to the row above, and then we'll center align this again using Alt HAC, and now we'll go ahead and drag this down. And instead of holding my finger down on the down arrow key or tapping it many times, we can use the page down key, which will allow us to jump down. And then we can also see Excel is counting the rows for us. And so once I get to around 360, I overshot a little bit. I can delete the excess, and there we have 360 months. To navigate back up, we don't want to use our mouse. We could hold down Control and the up key, and now I'm back to the top of the sheet. Or if you ever find yourself somewhere random in the sheet, so now I'm in the bottom right, I can hold down Control and Home, and now I'm back in cell A1. So now we're ready to build out the year column. And so the way that we're going to do this is by using the roundup function. What you definitely don't want to do for 2 reasons. 1, it's extremely inefficient, and 2, it's very much subject to human error, is try to hard code the year that corresponds to each month. That's going to take far too much time. The way that we do this is by using the roundup function. And we see that this function rounds a number up away from 0. And so what we're going to do, first we're asked to input a number. We're going to select the month number and then divide by 12. That's the number. And then comma for the number of digits. This is asking how many digits do we want to round up. We're going to say 0. This will round us up to the nearest whole number. We'll close parentheses and hit enter. And so we see we have year 1 corresponds to month 1. And then as we drag this down, month 12 corresponds to year 1, but then once we got to month 13, this corresponds to year 2, and so now we can drag this formula down. And a way to even be more efficient about dragging formulas around the spreadsheet is I'm going to jump down to the end of the month column by holding down Control and the down arrow key, navigate over to the F column, and then hold down Shift Control and up, and then Control down to drag this down. That way I don't need to incessantly tap the down key or even page down. This is even a more efficient way to project the year or really any schedule that you're building out without, especially in time sensitive scenarios. So we have that. For the beginning balance, we have this in our loan summary. It will be the loan amount. And so we'll link to there. For the interest payment, we calculate this by taking the beginning balance and multiplying by the interest rate. But again, we need to be careful here because the interest rate is given to us on an annual basis, so we need to divide by 12. And so we'll lock in the cell using the F4 key, and then we'll divide by 12 to get the monthly interest rate. And so there we see the monthly interest payment is $50,000 in month 1. For the principal payment, the way that we're going to calculate this is by taking the monthly payment and deducting the principal payment, because again, the total payment is the sum of the interest payment and the principal payment. However, we need to account for 2 things here as it relates to timing. In this amortization schedule, in this loan, we have a 12-month interest-only period. And so just as the name suggests, interest only means only paying interest during that time, and so there should be no principal payment. The other consideration is that we need to account for the maturity, just how this amortization table will be built. We don't want to show any principal payments after the loan has been paid back, so after the maturity month. And so in order to do this, we need two if statements. This is called embedded if statements, and we'll go ahead and build that out now. So I'm going to type in equals if, and my logical test will be the month that we're in. We're going to test if that is greater than the maturity period, so 120 months, and we'll lock in that cell reference, again using the F4 key. Our value, if true, should be 0. And again, if we repay the loan, there is no principal payment to make, and so we should be showing a value, if true, of 0 here, which in other words says that no principal is being paid at that point in time. For our value if false, this is where we embed another if statement. We're going to type in if again. This time we're going to test for if we are in the interest only period. So we'll go ahead and select the month that we're in, and we'll test if it's less than or equal to the interest only period, so 12 months, and we'll lock in that cell reference as well. If we're in the interest only period, guess what? We're looking to calculate the principal payment. It's the interest only period. Therefore, it should be 0. So our value if true and this second if statement is 0. And then our value if false, meaning that if we are still in the life of the loan, so the loan hasn't been paid back yet, but we're also outside of this interest only period, how do we calculate the principal payment? We have the total monthly payment here, and we'll lock in that cell reference, and we'll simply subtract the interest payment. So we're actually backing into the principal payment by taking the total monthly payment, which again is the sum of principal and interest, and then subtracting out the interest payment. So this is just some simple algebra here. Then we'll close parentheses once to close out the first if statement, and then again close parentheses to close out the second if statement, and then we'll hit enter. And then we see we have a value of 0 here. We'll go ahead and copy this cell, and then Alt-ES to open up the Paste Special menu, and then T to select formats. We'll hit enter, and we see that the principal payment is $0.00. And the reason for that is we are in the interest only period. To calculate the total payment, we're going to take the sum, as we know, of the interest and principal. Nothing fancy there, and there's our total payment. We're only paying interest because we're in month 1. We have a 12-month interest only period. No principal. Our total payment, sum of interest and principal. No principal there. Total payment is $50,000. And now for the repayment, this represents once we repay the loan. This will only occur at the maturity. And so what we're going to do here is we're going to need an if statement. So we'll type in equals if, and we'll test if the month that we are in is equal to the maturity, and we'll lock in that cell reference. And so if we're in the maturity month, we'll take the beginning balance and we'll subtract out any principal that was paid during that month as well, because we don't want to double count that. That's our value if true. Value if false, meaning that if we are not in the maturity month, then we'll show a value of 0 because we shouldn't be repaying the loan if we are outside of the maturity month. We'll go ahead again, we'll copy this formatting and Alt-EST to paste it here. And then for the ending balance, what we're going to do is we're going to take the beginning balance, subtract any principal, and then subtract the repayment amount as well, and that's our ending balance. For the beginning balance, after month 1, it will simply be the ending balance from the previous month. And then these formulas, we can go ahead and drag these down. Actually, what we're going to do first is get rid of these decimal places by selecting these cells here, and then Alt H9 and then Alt H9 again allows us to get rid of those decimal places. And then we'll do the same thing here. And again, this just gives us a cleaner look to the amortization table. And now we'll drag these formulas down here. We need to be careful not to drag down this formula since this is linking directly to the loan summary. If we drag this cell down, it will throw off the entire table. We don't want to do that, but we can drag from row 2 or from month 2 and going down. And again, to do this faster, I'm going to hold down Control and the down key, and then I'm going to select our range here, and then Control Shift up, and then Control D to drag all of this down. And now we have our amortization table here. Now I'll just finish formatting this by holding down Control Shift and the up key to select the entirety of the table, and then Alt HBS to add a border around. And so now we'll take a look at the table. So first and foremost, we have an $8 million loan, which we see here, that's our beginning balance, with a 12-month interest only period. And so if we look for the first 12 months, we only have interest payments, which is exactly what we want to see. The ending balance is not going down. And another thing that many people confuse is that interest will not affect the outstanding loan balance in this very simple circumstance. For those of you who know what PIK interest is, this isn't regarding that. Capitalized interest, we're not concerned with that in this scenario. Interest should not be decreasing the ending balance. And so if we look at the dependence for this formula, we are skipping over interest. We shouldn't be including that. The only thing that is going to decrease the ending balance will be the principal payments and the repayment, which is inherently a principal payment as well. And so we see again for the first 12 months, we don't have any decrease in the ending balance because we only have interest payments. But then once we're out of that interest only period and the principal kicks in, we see that the balance is gradually going down exactly by the amounts of principal that we're paying down. And then let's go ahead and take a look at the maturity, which occurs in month 120. So we'll jump down to month 120 and we'll take a look. We see that we are paying down the loan completely because this is when the loan comes due. And so the ending balance at the end of month 120 is 0 because we repaid the loan. And so now that leads us to the balloon payment. So what is the balloon payment? As I mentioned at the beginning of the video, this refers to the lump sum or the large amount that's paid once the loan becomes due. So at maturity again. And we saw that in month 120. So to calculate the balloon payment, what we'll do is we'll take the loan amount, and then we're simply going to subtract the sum of all of the principal payments in the amortization table. And so there's the balloon payment. And then if we go back to month 120, just as a quick check, we should see that exact number, and we do. And so we can be confident that the table is flowing correctly. Now, how do we get rid of the balloon payment? Again, as I said at the beginning of the video, this is the result of the amortization period exceeding the maturity. So the first thing that I'm going to do is set the interest only period to 0. And now we see the table updates seamlessly. And then in order to get rid of this balloon payment, all I need to do is make sure that the amortization period is equal to the maturity period. And so if I set this, change this from 360 to 120, there is no balloon payment. Why? Because we have 120 payments to make and the loan is due in 120 months. And so we're paying it down exactly when we get to month 120, which is what we see here. So that's why there is no balloon payment. Even if the amortization is 121 months and the maturity is 120 months, there is going to be some balloon payment, albeit however small, it's still going to be there simply because we have 120 months to pay back the loan, but we're paying it as though we had 121 months. And so as long as the amortization period exceeds the maturity, which is the term, we're always going to have a balloon payment. And so again, once they're equal to each other, that's fine. We see that there's no balloon payment. I'll set this back to 360. And then we see we have a much larger balloon payment. And again, this model is fully dynamic. That's the way you want to build things because this will save you much time in your career instead of staying up late all night trying to figure out how formulas are flowing. This is a nice institutional grade amortization table that will allow you to seamlessly see how debt is being serviced on your real estate deals. So I hope this video was helpful. If you're looking to learn more about thanks everyone.